All right, so in example B here, we have one of the angles and two of the side lengths. So I'm just going to start drawing a triangle. And let's see. I know that angle A, capital A, is 53 degrees. And so that's going to make this 79. And I know that this B is 35. And I'll draw my height H here. And then I'm going to go ahead and I actually don't know this length here. So just going to dash that. And then we have our two angles. So this is angle B, and this is angle C, and then this is side length C. And I'm going to label my height H here. And so I think the first thing that I want to do is I want to figure out H. And so I'm going to take sine of 53 degrees, and sine is opposite over hypotenuse. So that's going to be H over 35. So H ends up equaling 35 times sine of 53 degrees. Let me make sure I'm in degrees, and I am. So then I want to do 35 times sine of 53 degrees. And notice here that all of the side lengths and angles are in whole numbers, so I'm going to round that to the nearest whole number, which is 28. Okay, now here we have that A is greater than the height. And so now we need to look at A in relation to B. And we know that A here is greater than B. And so we are in the scenario or case where we're only dealing with one triangle. So we don't have to worry about there being two triangles or zero triangles. So we know comfortably that there is one triangle, and now we can figure out the other angles and side lengths. So let's see. I'm going to set up one of my ratios. I'm going to do this, and I know that sine of 53 degrees over 79 degrees is equal to sine of capital B over 35 degrees. Now, in previous examples, we were solving for side lengths. Here we're solving for an angle, so we will eventually need to use sine inverse or arcsine. So if I use algebra and multiply both sides by 35, then we get sine of B is equal to 35 times sine of 53 degrees over 79. And then if I apply arcsine or sine inverse on both sides, then we get capital B is equal to sine inverse of 35 times sine of 53 degrees over 79. So let's go ahead and see if we can throw that into our calculator. So I have sine inverse of 35 times sine of 53 divided by 79. And I'm going to round that to the nearest whole number, so that's going to give me that b is equal to 21 degrees. So I'm going to put 21 degrees there. And now that I have two of our angles, I know that a plus b plus c is equal to 180 degrees, and a is 53 degrees, b is 21 degrees, and c I am trying to solve for. So I'm going to use my calculator to do this. 180 minus 53 plus 21 gives me 106. So C is equal to 106 degrees there. And now we just need to find the side length C. So I know that C, lowercase c, over sine of 106 degrees is equal to 79 over sine of 53 degrees. And notice here that I'm using the a's to create my equation, but you can use the b's as well, and you should still get the same value. So maybe test that out later and see that it in fact works for both the a's and the b's. So if I use algebra to solve this, I'm going to get that c is equal to 79 times sine of 106 degrees over sine of 53 degrees. And let's go ahead and throw that into our calculator. And if we're rounding that number to the nearest whole number, that should be 95. So we know our C length is 95, and that completes this example.